Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi everyone, welcome to today's session of Dynamic Programming series, and I'm very pleased to see you all here. And before we begin, can I please get a quick confirmation if my voice is clearly audible? Hi Rishit. Can I please get a confirmation if my voice is audible? Yeah, okay. Thank you so much. Now let me share my screen. Hi Nikaj. Okay, so this is our day 14 of Dynamic Programming series. And then let's just wait for a couple more minutes so that rest of our friends also join. And then we shall be starting the session. Hi, Nix. Okay. Okay, so we are good to start our today's session. And uh, let's just start with the first question. That is the question tab visible? Okay. So we are starting with first question of the day, which is the strictly increasing array. Okay. So what is the question? Given an array nums of n positive integers, find the minimum number of operations required to modify the array such that array elements are in strictly increasing order. Okay. So changing a number to greater or lesser than original number is counted as one operation. So let us first try to understand the question statement with the examples that we have. Anyone knows how to add a new page here? Do we don't have? Okay. I think maybe we'll get it after some time. Okay, so the question that we are doing is strictly increasing array. Okay. Um, I don't think this is working. Thanks, Akash, for the compliment. Actually, something went wrong with the Microsoft OneNote today. I don't know what's the issue. So I'm not able to access it. So that's why today we are using this Miro website. And here also, I don't know how to add a new page. So maybe I should try something. Just give me a moment, guys. Okay. Till then, what you can do is all of you can try reading the question. And if there are any approaches that is coming to your mind, all of you can share it. Okay. So we will do this sliding thing. Okay. So the first question that we are doing is strictly increasing array. Okay. Now let us look at the what is the input and the output to the question. The input that is given is an array is given to us. Okay. And what is that array? 1, 2, 3, 6, 5, 4. Okay. So input is 1, 2, 3, 6, 5, 4. Okay. And the output to this question is 2. Pi 2. All right, next. Thanks for informing me about this. So, like, maybe we can do this up and down kind of thing. Okay. And also, if any one of you will face any issues or any uncomfortability with this page, please do let me know. Okay, I'll try to make it thoda sa easier for all of you. All right, so the input is 1, 2, 3, 6, 5, 4, and the output that we are getting is 2, right? So what here, as you can see, that we are having an increasing array, and like if you will check for all the elements here, like 1, 2, this is increasing, then 3, this is increasing, but then here, yeah, 6, this is also increasing, but then after that we have 5, which does not satisfy the property, and then after that we have 4, okay? So what you can say is that we need to remove two elements, or like we need to perform the operation two times so that we can have a strictly increasing array, right? So that's why the output to this question is 2. Okay. And if you will look at another input that is given to us, that is the second input given to us, that is 1, 2, 3, 4. Okay. So, and the output to this is, if anyone would like to guess the output for this question. How many elements do you need to change? How many elements do you need to change to get this array in strictly increasing order? Zero, right? Okay. So Rishit and Anik, that's the right answer. We need to change zero number of elements. Exactly, Nikaj, right? So basically, the question here demands is that how many elements you need to change inside the array so that you can make it in a strictly increasing order. Okay. Now tell me one thing. We discussed about two arrays. Now let me make a table. Yes, next, that's the right answer. Length of LIS and the final answer. Okay, so the first array that I have is 1, 2, 3, 6, 5, 4. All right, everyone, tell me what is the length of the longest increasing subsequence in this array? We have discussed the question of longest increasing subsequence, right? So if any one of you can tell me the length of the longest increasing subsequence here, 4. Yeah, exactly. Next, that's the right answer. The length of longest increasing subsequence is 4. Rishit, 6. Why? Yeah, 4. Nipun, Anik, every one of you has given the right answer. Srinivas and Naikaj as well. Okay. And what is the final answer to this question? Like how many operations we needed to do to change it into yeah, 1 2 3 6 or 1 2 3 5, 1 2 3 4, any of the sequence you can do. Yeah, that's right answer, Nipun. We needed two operations. Okay. Yeah, so as all of we can see that Nix has already made the deduction that what we are doing here, okay? But let us just try to understand with one more example. All right. If this is our array 1 2 3 4, what is the length of longest increasing subsequence here? This is our second example to the question. 4. Yeah, length of longest increasing subsequence is 4. And what is the final answer to this question? Yes, Nipun, that's the correct observation that you have also deduced. So the final answer is 0, right? So are you guys able to see the relation that what we are generating? See, basically in the question, the demand was to have a strictly increasing array. Okay. So what you need to do is if you want to have increasing array, so just have a count of that. What is the length of the longest increasing subsequence? Yes, next. That's the correct answer. 4 minus 4 0. Okay, so basically if you want to have an increasing array, so what we need to do is that find out the length of the longest increasing subsequence. Why? Because that is already in increasing order, right? Now once you have that length of the longest increasing subsequence, and then what you can do is you can subtract the length of the array from the length of the longest increasing subsequence, right? Because it will give you the elements that are not the part of the longest increasing subsequence, and which means that those elements need changes, right? So that is why answer is coming in this way. Basically you will see that in array, find length of longest increasing subsequence, right? So if you will find the length of longest increasing subsequence, what it will give you? It will give you the set, okay, that is already in increasing order. Now if a set is already in increasing order, you don't need to touch it, right? So what you need to change? You need to change the elements that are not part of those increasing order, right? So basically what we need to do is after finding the length of longest increasing subsequence, subtract the length from total length of array, okay, that is n, from total, yeah, exactly, Nipul, that's right answer, from total length of array, that is n, right? So are these 2 points clear to you all, and why we are doing this? The question was to find out that how many operations we need to perform to have an array in strictly increasing order, but as we saw that the question boils down to basically find out the longest increasing subsequence. Okay, so these all are just a part of observation. It's not that for every question you need to have different approaches, right? You can have just one approach, and then you can use that one approach uh, when you can use that one approach to solve multiple questions. Okay, now here how we got the idea of using this LIS concept, because see, what does LIS stands for? Longest increasing subsequence, right? Now the question demands that you have to make the array strictly increasing, right? So tell me that there is this thing strictly increasing in longest increasing subsequence. Also, the thing is strictly increasing, right? So if you want to make an array strictly increasing, what you need to do is you need to change the elements who are not in strictly increasing order, right? So from there you can have this intuition that maybe we can use LIS to solve this question. Okay, like you saw now that what elements are not part of this increasing subsequence. The answer is basically uh, that number of elements, right? So that's why what you need to do is you can have this intuition that if this is the strictly increasing thing, and the strictly increasing thing is there in LIS also. Like both of these questions are having lot many things in common. Okay, in both of these we need to have an array in strictly increasing, which means we need to have the count of that how many number of elements are there who are strictly increasing, right? Here also we are maintaining that count, and here also we need to maintain the count. So rather than using the different approach for this question, you can use this approach to get the final answer, right? And also, as you can see, when we discussed that longest common subsequence question, okay. So, and after that, we discussed one's longest palindromic subsequence question, right? So you saw that, how this longest palindromic subsequence was derived from this LCS. There was just a very basic formula that we used, okay? And on the basis of that formula, there was no any code for LPS, okay? It was entirely based on LCS. And then there was one question that minimum number of insertion and deletions required, right? To make two strings same. So again, there was no any new code for this. What we did, we used this LCS wala concept, and then we implemented that concept in this question. Okay, so basically what I'm trying to say is that for all the different questions, you don't need to have different approaches. Just you need to find out, what this question is basically boiling down to. Okay, sometimes question just boils down to a very simple statement. So you just need to find out that simple statement, the true meaning that is hidden behind the question, and then the question will become pretty easy. Okay, so this question, it can be solved in two steps. Find out the length of longest increasing subsequence and subtract that length from the total length. Okay, so we are already familiar with the longest increasing subsequence. So let me show you the code for this question. Okay, if any issues in understanding the code, yeah, exactly, Nix. LCS and LIS are very important because they are basically, in DP we have types of questions, so they basically consist of a type of a question, right? So that's why you need to have a strong hold over LIS, LCS, knapsack. Okay. Uh, is everyone able to see the code screen? This is just a basic code that we used for longest increasing subsequence, nothing new. Okay, and then just in the end you need to return n minus whatever is the maximum element. Okay, because as you can see in the longest increasing subsequence, we used to return the maximum element. Okay, that is the length of the longest increasing subsequence. Here you need to return the n minus maximum element, right? So just write down the code for the longest increasing subsequence and add this new line. So that is the code for this question. All right, and please give me a +1 if the question is clear to you all, so that we can move to our next question. Thanks, Nipun, for +2. Thanks, next Rishit. All right, so let me now move to our second question. And actually, I guess this Miro is better. I don't now need to do that for switching. I don't need to stop sharing screen again and again. I can just switch tabs. So here we are having the next question, that is smallest sum contiguous subarray. Okay. Mm. All right. So let me read out the question statement. It reads as, given an array of n integers, find the contiguous subarray containing at least one number which has the minimum sum and return its sum. Okay. Yesterday we did a question of maximum sum contiguous subarray, and today this is the smallest sum contiguous subarray. Okay. There is not much of a difference. The difference is only that it was a maximum sum and it is the minimum sum. Okay, so the very basic difference that we expect here, that is implemented in the code only. As we can see, the example that is given to us is 3 minus 4, 2 minus 3. Okay, so the question that we are doing is smallest sum contiguous subarray. Okay. Now the first input that is given to us is 3 minus 4, 2 minus 3, 3 minus 4, 2 minus 3 minus 1, 7 minus 5. Okay, and the output to this question is contiguous subarray. It has to be minimum minus 4 to 1. So if you select this subarray, okay, in this you will get the maximum sum, that is minus 6, right? 4, 5, 6, 7, 8. Yeah. So the minimum sum that we are getting here is minus 6. That is the answer to this question. Okay. So input and output statement, I hope it is pretty much clear to you. There is nothing of there is nothing that required much detailed explanation. So let us see how we can do it. Yesterday when we did the question of maximum sum contiguous subarray, okay. So if you remember the code for that question, what we basically had was we initialized, we had a final answer variable that was res, okay. So we initialized it with int min. Here we are going to initialize it with int max, right? Because we need to find the minimum sum, okay. And after that what we did was we were updating our current max, right, while we were iterating the array. So I can write it here as for int I is equal to 0, I is less than, and I plus plus. Okay, what we are doing is we are iterating our array. Okay, so while iterating the array, you need to, let us say we have created a variable current minimum. Okay, it is keeping the track of the minimum elements that we encounter till this point. Okay, so I would like any one of you to help me with this. That what shall I write down here? Current minimum is minimum of what? I'm sorry. Yeah. I'm sorry for this experiment that I just performed. Yeah. So current minimum is minimum of next maybe you can write down the more perfect answer. You are very close to it, but then maybe I think that's not the correct answer actually. Like one of the element is definitely array of I. What will be the other element? Like we just did it in the previous session, guys. I hope any one of you will be able to answer this question. You are finding out the minimum. Yesterday when we did the maximum question, the continuous maximum sum contiguous subarray, there we were updating our current max, right? How we were updating our current max? Okay, do I need to explain yesterday's question again, that cadence algorithm? Let me show you the code for cadence algorithm, okay, that we did yesterday. I think we need some help from there. Okay. Yesterday when we were doing the cadence algorithm question, at that time we updated our current max as I said, there were two choices. Okay, like if this is an element, we were making two choices, and what were those two choices? That either to add this element or either to not add this element. Okay, so when you were adding this element, you were doing what? You were adding it to the current sum that you have till now. Okay, or what you can do is you can simply just continue with this statement, with this element, without including the previous sum, right? So in this case also we are going to do the same. Like we are going to have current minimum of what? The minimum of either it could be the just the array of I, or current minimum plus array of I. Okay, all right. Like either you can decide, as I explained in the previous section, previous session also. Okay, I would request you all to just please just go back and once try to see from that previous session also, that what I have explained there. Okay, so basically what we need to decide, that either this current element is in itself enough to continue, or either we need to add the previous sum that we have obtained till now. Okay, there are two choices that we are making, so that's why we found the minimum out, we find the minimum out of these two choices. And in the maximum case also, we were finding the maximum out of these two choices only. Okay, so just make sure that you are visiting that previous session also, the concept will get more clearer to you. All right, and then what you can do is simply you can update your res. Okay, res will be what? Just minimum of, okay, res and current minimum, and then at the end you can return res. Okay, so as you all saw here, that this question is just a very basic variation of cadence algorithm, right? It was a maximum sum contiguous, it is minimum sum contiguous. Okay, so as you can see that even after that we were facing certain difficulties in solving this question. So that's why it is very important that all of you practice the questions as well, right? So that you can have a better approach towards the questions. You just needed to, like, it is a very similar question. Okay, just all of the words there that was written with max is replaced with min here. Okay, and these are the two choices that we are making: either continue with the new element, or either add the previous element sum with the new element. Okay, so in that way you will get your answer. And now let me share the screen. All of you can view the code. Please give me a +1 in the chat section if the code is clear, or if there is any doubt, then do add that doubt in the chat section. I will make it clear to you. I hope the screen is visible. I don't need to switch off the camera. Thank you, Shishir. Thank you, Rishit, for the confirmation. Okay. Are we good to go towards our next question? What is the board that you guys are doing here? All right, and like, okay, before we move on to the next question, I would like all of you to write down in the chat section what was your most favorite DP question that we covered in this session. And I want all of you to answer it. Okay, right now we are having 11 participants in the chat section. So I want all 11 answers to be there. If all of you can do it, then please, it would be very nice. Just tell me about what was the best question that we have covered in this session. Let us see what's that and which question gets the majority of votes. Okay, let me post mine also. Mine was actually LCS. Okay, Naikad. So it's LCS and LBS. Okay, and mine was LCS actually. It's LIS. What is LBS? Okay, so other people, they are not having any favorite question that we did. MCM, yeah, that is also very interesting. I really want all of you to answer it, okay? The favorite question. My favorite was LCS. Yeah, it seems like that they are not liking DP, or I mean, DP is an interesting concept, and like right now in these days, it is most widely asked in interviews as well. Maybe they liked all of the questions, so that's why they are not able to figure out what was their most favorite question. Let's just take it in a positive way. So I really hope, guys, that all of you liked all of the questions, and that's why you don't have any favorite question as such. But that's again a very good thing that you liked all of the questions. So now let us move towards our next question of the day. And like, the chat section is open, guys. If anyone feel like adding any of the topics at any time, you can do that. Okay. Let me discuss the next question till then. Okay, so the question that we are going to discuss is a very famous graph algorithm. All right, that is Floyd-Warshall algorithm. All right, so you joined just before this last question. No issues. You can always visit the practice channel of Geeks for Geeks, that is GFG Practice, and then you can look for the playlist there, and then you can access the sessions. Okay, if you are interested. So we have this Floyd-Warshall algorithm. What does it say? The question says is the problem is to find the shortest distance between every pair of vertices in a given edge-weighted directed graph. The graph is represented as an adjacency matrix of size n cross n. Matrix ij denotes the weight of the edge from I to j. This is also one of the method to represent the graph, right? We have an adjacency matrix, and we do create other methods also, but adjacency list. This adjacency matrix is also a way. Okay, and as we know that in adjacency matrix, what happens is that if ij is -1, it means that there is no path. Okay, and if there is any value that is given in the matrix, it means that there is a path, and this is the weight of the path. Okay, so let me just explain to you the question. So what we are discussing it. Yeah, that's correct, Nikaj. We need lots of practice to conquer DP. So what we are discussing is Floyd-Warshall algorithm. A very famous graph question, right? And it uses the concept of DP. Where is it? Where do we have eraser? Oh, I'm not getting any erasers here. It was just right here, right? Okay, let's just move it. So I lost the pen also. Or what? Yeah. Okay, so this is the eraser. So we are discussing Floyd-Warshall algorithm. Actually, I missed H there. Okay. Now, what is this? This question, like, let me firstly discuss some of the key points of this algorithm. The first key point is that this is used to find the all pairs shortest path. Okay, the shortest path between all the pairs that we have. Okay, clear. And the next important thing is that problem is used to find shortest path, and also its time complexity. You can say that it is kind of a brute force as well, because its time complexity is like, it's like to the power of 3. Okay, so problem is used to find shortest path between each pair, between each vertices. Okay, all right. And the next thing about this question is that it is DP based, and the time complexity of this question is going to be big O of cube, and the space complexity is big O of 1. We are not going to use any additional space. Whatever matrix is given to us, what we will do is that we will update that matrix only. Okay, so we don't need any extra space for that, but we need a time complexity to the power of 3. Okay, yeah, this is the most optimized approach for Floyd-Warshall algorithm. Okay, other than Floyd-Warshall, there are other methods to find the shortest path, that is the extras is there. Okay, but if you want to find out the shortest path between all the pairs, okay, so for that we have Floyd-Warshall algorithm, and this is it most optimized approach, right? So now basically what we do here is, let us say we have matrix, okay, I and j, the loop that we are iterating, and then let us say the n is the size of the matrix. Okay, it is of n cross n. Okay, so basically what we do is, let us say if you want to find a shortest path between I to j. Okay, what do I mean by shortest path? Path having the least weight, right? So if you want to find out that, let us say I will create an intermediate vertex k. Okay, and the value of k will again range from 0 to n. Okay, now what does this k is supposed to do? K will lie somewhere, in between I to j. Okay, Like it can lie at any of these points. And what k is supposed to do, it will find out that whether the direct path between I to j is the shortest, or whether the path from I to k plus k to j is the shortest. Okay, this comparison is done at every iteration. And whenever we find that, if, let me write that, if condition, if matrix at ik plus matrix at ij, oh, sorry, matrix at kj, right? Matrix at ik, matrix at kj is the matrix. Okay, so if this sum in total is less than matrix at ij, right? If this sum is in total less than the matrix of ij, then basically how we update the path is we write matrix at ij is equal to matrix at ik plus kj. Okay. So what k is playing role here is you will check that, like let us say if path from I to j is given as its weight is 25, okay, and there is a path from I to k whose weight is 10, and there is a path from k to j whose weight is 2. Okay, so out of these two, what is minimum? Obviously this is giving you 12, this is giving you 25. Okay, so this 12 is minimum, right? So now what you will add is that if you want to go from I vertex to j vertex, then rather than going directly, what you can do is you can first go from I to k, and then you can go from k to j. Okay, so we have broken it down, right? So the intermediate vertex that we have here, that is k. So we have two choices here, either to include it or either exclude it. Okay, right? So we have these two choices, either include, either exclude. So when you are including, what you do is I to j is changed from I to k plus k to j, right? Or when you are excluding it, then the path from I to j remains as it is, right? We don't update it with any intermediate path, right? So this is the very basic key idea behind the Floyd-Warshall algorithm. So shortest path using at most one curved edge. All right. As this question, I guess, does not belong to this DP category, but then, okay, all right. If you have mentioned this question, I will just note it down. Okay, just give me a moment. Shortest path using at most one curved edge, right? Okay, so maybe we will be taking up this question in a category where this question belongs to. All right, so that question will be solved, or maybe what you can do is you can post this question in the Discord channel also, so that mentors who are there, they can help you out with this question. Okay. All right. So, is everyone clear with this concept behind the Floyd-Warshall algorithm? What we are basically doing is we are iterating the intermediate vertex k from 0 to n. Okay, and then we are iterating I and j as usual, 0 to n, and then we are checking that whether the path from I to j is shorter than, sorry, is greater than the path from I to k and k to j. Okay, so if that condition is satisfied, then we are updating it with this new path. Okay, so this is the idea of Floyd-Warshall algorithm. So if this is clear to you all, please give me a +1 in the chat section. All right, thank you, Rishit. And thank you for being such a dedicated audience throughout the session, Rishit, Naikaj. Then we have some more people here. Nix, Nipun. Okay, guys. So let me now show you the code for this question. Okay. You guys aren't having the link to the Discord group. Wait. Like there's this Discord channel for the Geeks for Geeks group. There you can post any of the questions that you want to. Okay. Let me share that. Yes, exactly. It is a three nested loop. One for K, that is an intermediate vertex, and one for INJ. Now, what I need to understand is that how are we sharing the link? Just give me a moment, guys. Okay. Okay, so I will post it in the chat section. So this is our Discord group that you can join. Okay, and from this channel you can post your. There are like several servers there. Okay, you can join any of the groups that you want to, and then you can post your questions. Mentors will be there to help you out. All right. Okay, guys. So is there any issue with the code? Do give me a +1 if the code is clear to you all. What I'm doing is that I'm iterating for the intermediate vertex, then I'm iterating for you're most welcome, Rishit. Then I'm iterating for the I and J vertices, okay, and then I'm checking if matrix of I k is not is equal to -1. That is that there must be a path from I to k as well, and there must be a path from k to j. Okay, in that case only you can check. And now I will check that if matrix of ij is not is equal to -1. Okay, that is if there is no any path between I to j, then simply update it with int max and then do this comparison. Okay, so as you can see we are doing here in place modification, so we don't need any additional space for that. Okay, so this is the code for this question. I hope it is clear to you all. And now let me show you the brief timeline. K is the outermost loop because it is like, it is the intermediate vertex. We need to start it from 0. We need to end it from n. And like, it is not going to create much of difference. Okay. If you can like place it anywhere inside, just we need to have it value from 0 to like 0 to n. Okay. You need to try all the vertices that are there from 0 to n. That's the main concept. Okay. You can place it anywhere you want to. Okay. Now, what have we covered till now? We have covered knapsack, and we have covered LCS, and next we covered stock. Next we covered cheese. Next we had grids. Next we had stock, cheese, grid. We had MCM, and then we had practice sessions. Okay. So, this was a 14-day series. Okay, so these were the concepts that were covered in those series. We covered the knapsack problems, the LCS, stock-based problems, trees problems, grids problem, and MCM. Okay, and then we had some practice sessions where we solved the questions based on DP. Okay, so that was all about the session that we had for this 14-day. I hope all of you liked the session, and I really hope that the session will be helpful to you in your preparation. Okay, any feedback, any compliments for the sessions are welcomed. The floor is open to that, and also we will be soon getting back to many more such amazing sessions. Okay, stay in tune with us. This was the last day of this DP series, and I also had a great time interacting with you all and conducting this session. I hope all of you liked the session as well. So let's just hope that we meet soon with some another amazing series. And all of you who are who have joined the session today only, what you can do is that you can access the playlist from the channel, okay, and then you can access all the sessions that have been conducted till now. You're most welcome, Rag. All right, guys. So that was our DP question, DP series, and I wish you all the very best for your preparation. And I hope all of you will do lots of hard work and will get what you all deserve. All right. Thanks everyone for being with me throughout the session and for all the motivation. All right. Are we having any doubts in today's session? Or if we don't have any doubts, then we are good to wrap up this session of today's. Okay, all clear. Welcome, Rishit. So thank you everyone for being with me, and make sure that you are doing the hard work. Stay safe, everyone. Take care, and good night, everyone.